Hello, Integrated Science 2 class. This is part 2 of mechanical advantage of levers. So we're just going to keep going here. I'll give you some hints on some of these other problems. Problem number 2, what's the mechanical advantage of a lever with an input arm of 3 meters and an output arm of 2 meters? Go back and take a look at exactly how you did number 1. You can follow those directions for this. Again, this could be either a first or a second class lever. It doesn't matter to me how you choose to draw it. Just do it as neatly as you possibly can. Now, for some of these problems, like number 3, it says a lever with an input arm of 2 meters has a mechanical advantage of 4. What's the output arm's length? So this is where it might be helpful to jot this down, where we said that the mechanical advantage is equal to d in divided by d out. We can rearrange these variables a little bit. Notice in this case, we're asking to solve for the output arm. That's your d out. So in this case, let me give you a couple equations. So d out will be equal to the length of the input arm divided by the mechanical advantage. And if you were asked to solve for distance in, that's going to be the mechanical advantage times the distance out. So these are just the same equation where we've rearranged the variables. So if you need to solve for d out, here's your equation. If you need to solve for d in, here's your equation. So what does this look like? It says a lever with an input arm of 2 meters. So you should always write down what you're given. So dn equals 2 meters. Mechanical advantage is equal to 4. And distance out is what I'm trying to solve for. Is there an equation for that? You bet. Distance out is equal to distance in divided by mechanical advantage. I have both of those. So that's 2 meters divided by 4. And that's going to be 0.5. Now notice I've got units here, so I have to, and I'm solving for a distance. So it'd be 0.5 meters. So for number 4, you're asked to solve for the length of the input arm. So you're going to want to use the second, or actually the third equation I have over here on the left-hand side to do that one. These last 3, number 5 is a rake, number 6 is a broom, number 7 is also a rake, just a smaller rake. But these are all third-class levers. So if you want to diagram this, it says, here's the rake. And you have to remember the fulcrum is up here. You're applying the effort here. So here's your force in. And you're trying to rake leaves here. So there's your force out. The input arm is 0.4 meters. So that's the distance from the fulcrum to the force in. So that's 0.4 meters. And if we measure from the fulcrum all the way down to here, that's our output arm, so that's 1 meter. And remember, mechanical advantage is equal to distance in over distance out, which equals 0.4 meters divided by 1.0 meters. The meters will cancel, and my mechanical advantage is 0.4. Typically, third-class levers will have mechanical advantages less than 1. I think given that information, you should be able to do number 6 and also number 7. Just try to show me all of your work. Don't take any real shortcuts. If you can make a little diagram, that's also very helpful.